For people responsible for the security of computer systems, the main goal should be to ensure safety of data stored in those systems. Previous policies assume that we can protect data on secure computers even if the computers are far from the source of the data. For instance, if you have the database server that is connected to 400 computers, you cannot guarantee its security by setting up a firewall on each of the machines. In the real world, nobody would protect information like that. For example, nobody would try to secure a very expensive painting, say the Mona Lisa, by setting up barbed wire entanglements half a mile before the painting. The protection is focused on the painting itself. We should employ a similar model of thinking with regards to data security. Previously, we have defined data security with regards to several categories. The first one was the level of access which unauthorized users have to confidential data. It is represented on the slide by the arrow, pointing out of the operating system, which shows data leak. How can you control data confidentiality? File access control is the most obvious solution. This means to grant access permission to read or write files and folders. Another solution is data encryption. This solution is more reliable because it works independently of external mechanisms. If a piece of data is encrypted, it stays encrypted even while the system shuts down. This is not so with file access control lists, which provide protection only until shutdown. It is problematic to strike a balance between the right amount of security and wide availability of data. The more effective the security, the harder it is to read the data. More effective measures of security require the user to confirm their identity by frequent and complicated identity verification procedures. Confidential data security always comes at the price, and the price is usually data availability. The protection of data integrity usually entails more than just purely technological solutions. File signatures do not guarantee that the file will not be modified. Here again, security policy, which we will discuss in detail later on, is essential. As is the case with data confidentiality, data integrity protection affects data availability. The more we try to secure data integrity, the harder it is not only to modify it, but also read the data. Data availability is the third aspect of data security. It is represented on the chart by the no entry sign. One of the goals of data security is to provide the highest level of data availability possible. We have already mentioned that availability can be achieved by professional technologies, such as high availability clusters or data replication strategies. Of course, 100% availability is by definition unachievable.